Hello everyone, I'm going to do a couple of short videos on basic trig by request, and I already have a lot of this on my geometry playlist, but I want to run through these pretty good, and I'll tag these under a new playlist in PreCal. So let's go ahead and get started. A lot of our right triangle trig is pretty straightforward, and it's based on the right triangle. And the key aspect of this is understanding how the function relationship works with our angle theta and the ratios of two sides. And it's which two sides determines which trig function we're going to play with. So here is theta right here, and that determines this is going to be opposite straight across the way, and right next to it is adjacent. Now hypotenuse is always the hypotenuse, it's that funny Greek word. So right across that way is going to be that. Now if theta were to change over here and make this my reference angle, these would have to be different. This would now be my opposite, and this would be my adjacent. Well, this sets us up for writing our trig ratios. Let's go ahead and do that. So we have our basic trig ratios, sine of theta, cosine of theta, and so on. So sine of theta, which think of when we do sine of theta as a function, f of x. That's my input. This is my input. That is my independent variable. This is the function, the very specific function, where this might have been like x squared plus 3 or whatever. This is the ratio of the adjacent over the hypotenuse. And that's what we have. I mean, did I say adjacent? Opposite over hypotenuse. Okay? So it's going to be opposite over hypotenuse. And then we have our cosine of theta, which is equal to adjacent over hypotenuse. And of course, our very important tangent function, very important invention in mathematics, which is going to be opposite over adjacent. Then we have our reciprocal functions, which are very important. And we're going to have our cosecant of theta, which is equal to basically 1 over sine of theta, which is equal to hypotenuse over opposite. And then we're going to have our secant of theta, which is equal to 1 over cosine of theta, which is equal to hypotenuse over adjacent. And of course, we have our cotangent of theta, which is 1 over tangent of theta, which is equal to our adjacent over opposite. Okay? Hey, stop it, stop it, stop it. Go away, go away. Opposite. Okay? Now, let's continue on and take a look at another example. And we'll run through these. So here's my reference angle. There's my opposite. There's my hypotenuse. And there's my adjacent. So running through these, we're just going to simply write this as a ratio. It's 33 over 65. Cosine adjacent over hypotenuse is 56 over 65. And our tangent, which is opposite over adjacent, is 33 over 56. These are reciprocal, so I'm just going to flip these. I don't even have to look at the triangle anymore. I'm just going to look over there and flip these puppies. Right? 65 over 56 and 56 over 33. Now, a lot of people don't like this fact that cosecant is the reciprocal of sine. They're thinking, well, why can't it be with cosine? That way I can remember it easier. Well, it's because math teachers are evil. Now, this was set up on how the circle relates to some of these segments and some of the properties that's going on inside these circles. And you may remember the term secant from your geometry, which is basically a line segment or a line that intersects the circle with points on the interior and exterior at two different locations, where the tangent intersects a circle at exactly missed 1 point. 1 point. Can't draw worth beans here. All right, moving on. So trig is based upon similarity, angle-angle similarity to be specific. And we're going to play with these 30, 60, 90, and 45, 45s in our unit circle. These come up very, very big. But if you remember, when we look at a circle, all circles are similar. And here I went ahead and kind of constructed a little triangle in there. So the angles don't change. But similar triangles, the angles are congruent and the sides are proportional. And what happened way back when, especially with the Greeks, was they started coming up with these ratios. That's how Eratosthenes determined the circumference of the earth all those many years ago. So what we have here is an angle, angle, these ratios of the, say, opposite over hypotenuse are going to boil down to the same decimal. That's what makes trig so powerful. Okay, let's go ahead and take a look at an example. Now, I used to have a Casio calculator on this computer, but I had to replace my hard drive because it just pooted out. This computer is like ancient. And I had a friend put in a hard drive for me, and thanks to him, he saved my computer. But I lost my Casio calculator, and it's kind of depressing. I'm hoping to figure out how to get that back. So what we have here is I have opposite and hypotenuse, and hopefully within 1 second you recognize that to be sine. Here's my angle. That's my function input. 20.75 is equal to 1200 over d. Now, I showed a shortcut in class where these basically swap over, but what's happening is you're going to multiply by d on both sides. I'll walk you through the algebra. That cancels out. So you're going to have d sine 20.75 is equal to 1200. Then you're going to divide by sine 20.75. Remember, this is a number. This is some kind of decimal. And what you do to one side, you do to the other. And I only usually show this once in class, and then I just start doing the shortcut. Those numbers cancel out because anything divided by itself is 1. And you have d is equal to 1200 over sine 20.75. And I already put this in the calculator here on my table here. And that comes to be about 49.8 degrees. Alrighty? So let's go on. I think that was, no, I got one more for you. Now we don't know theta. Remember, theta is the input to my function. And again, I have opposite and hypotenuse. So we're going to have sine of theta is equal to 12 over 15.7. This is an inverse function. Don't confuse it with reciprocal function. Inverse is basically we're going backwards. And if you ever had the opportunity to look at trig tables, now we're looking at the ratios and figuring out which degree goes with it. We input it in the computer, in the calculator, in this manner right here. There's no real algebra involved. We're just working backwards. And again, I knock this into, oops, I was looking at my notes. Did I do 49 point? That's the answer to the next one. This is 3,387 feet. Don't worry about that. Incident Blizz is risking, yeah, BlizzCon is interesting. Okay, so let's go and put this as 49.8 degrees. Okay, so we're done. I'm going to go ahead and get this loaded. Sorry about the, see, I need to get a new calculator. Alrighty, I'll get this posted and get going for the next one.